Hello students, welcome to SAM classes. Today we'll be starting a chapter differential equation, very important for KCT. Now around 3 marks we can expect from this chapter. Though the chapter is good and contains complex things, but still for the KCT it comes down to very minimal thing. Three things which I can point you out, which will be there for your KCT part. Now what are these three questions basically asked? One question is asked more or less pretty often from the order and degree part. Okay, so one question you can expect from here, one question from the formation or the solution part. Check the solution. Okay, from that part it comes, and one question maximum time comes from LD, linear differential equation. That's it. So three questions coming from the chapter, one from order and degree, one from either the formation part or the solution part, and one from linear differential equation. Okay. Now case study questions are very simple. Okay. So understand this chapter with ease. Let's talk about in details and brief about order and degree. So one question which is confirmed of differential equation is order and degree. Finding out the order and degree, which is very helpful for your PU syllabus also. Now let's see in a very simplest manner. What is order? Order of highest order derivative occurring in differential equation. Always defined, always positive. Now, what do you mean by this, sir? We didn't get anything. Okay. See this example. We have d3y by dx square means what? We have differentiated three times. We have differentiated three times. 2 into d2y by dx square means we have differentiated two times and then we have done square and all that. And then dy by dx we have differentiated one time plus y equal to 0. In this differential equation, what is the maximum time we have done differentiation? Three times. So what is my maximum time differentiation is what? Three times. So what is my order? So order is third order derivative. What is order? How many max times we have differentiated? Order is what everybody should say. How many max times, how many times maximum we have done differentiation? So third order derivative. Correct. We have differentiated this thing three times. So d3y by dx cube. Okay. So it is a third order derivative. So order is what? Third order. Now very simple. So order, I think so every student got it. What is order? Next, degree. Degree is nothing but positive integral index, positive highest power of the highest order. Once you have already found this is the order, now check if anybody is of third order. Nobody is of third order. So if this is only the third order, whatever its power is, that will be its degree. The degree is nothing but the exponent or the power of the highest order derivative. Exponent or the power of the highest order derivative. Now you'll say, sir, why positive only? Now see, if it is in minus something or something, you have to make it sure that it should not be in minus. You have to convert it in such a way so that it comes in the plus form. Okay, and it is always positive. Now, few places degree is not defined. We'll talk about that situation also, but at least I think so everybody is confirmed with order, correct? Now degree is defined only when it is polynomial equation in derivative. Now very important, mark this line. Polynomial equation in derivative means the derivative should be a polynomial function. Okay, the derivative, not x, not y. The dy by dx should be in normal. It should not come with sine, cos, log, tan, something like that, or e power x, anything. Okay, so I'll show you. I'll take multiple examples so it will be like clear. Okay, fully clear, don't worry. Now let's see one another example. So here in this example, students, what we have done, dy by dx we have means we have differentiated one time, then square it. Again dy by dx, again one time differentiation only, minus sine square y is equal to laddu. Correct. So what is the highest order? We know we have differentiated one time only. So highest order is what? We have done one time only. So one, correct. Now second thing is what is degree? So you'll say, sir, this is also one time differentiated, this is also one time differentiation. It has power 1, it has power 2. So what is the highest power? 2. So highest power is what? 2. Okay. Next, d2y by dx square is equal to fourth root 1 plus dy by dx whole square. Now what you do, see, the moment you see that dy by dx is not proper, it is like whole root or like fourth time, what do you do? Fourth root it means make the power 4 for all of it. So the moment you do, okay, you square double times. So you do dy by dx, this fourth root will be gone, correct? And then this dy by dx will be there. Now what you see is this is double derivative, correct? Second order derivative. So order is to what is the power of this? Earlier it had 1. The moment you did power 4, You did power 4 to remove this 1/4. Okay, what will happen? The power here became 4. So now the exponent has a power 4. So degree is what? 4, students. So don't do mistake. A lot of students, they do mistake by saying you have to bring it in such a form so that it should be in a, what is a different, dy by dx should not be like in a square root form or something. So you have to remove that and then you have to find the order and degree. Okay. Now coming to the next example, the moment I think so now a lot of students, they can directly say, sir, we can see it is a third order derivative, correct? Sine of dy by dx. Now we easily can say the order is what? 3. Very easy. But what about degree? I told you this dy by dx should come alone. Okay, it can be multiplied with x square, y square, something, but it should not be like sine of in composite form, like sine of dy by dx or cos of dy by dx. Okay, so here it is sine of dy by dx. It means it is not a polynomial function of derivative. So directly we can say not a polynomial function, degree not defined. Not a polynomial function, degree not defined. So anywhere you see cos of dy by dx, somebody will say, sir, log also, e power. Okay, so any higher non-polynomial, okay, any other non-polynomial function means not defined. Okay, degree won't be. Order is always defined, Virtue. Okay, order is always defined. Now we have, now what do you mean by, sir, y3 dash? It is same thing as d3y by dx cube. Okay, means third order derivative. Second order derivative, first order derivative plus y power. So third order, so order is 3. What about degree? Highest power of this. So 3 only one power was there, none. Now d4y by dx4. So we can say fourth order. What about tan? So tan came with the derivative. So degree not defined. Clear. So I think everybody now got an idea with these 6 examples. What is order? What is degree? And they can solve it very easily. Okay. So order and degree, now it is very clear. Let's see 2 more examples. E power y third order plus y second order whole square plus 10. Again, directly we can say order is 3 because we have differentiated 3 times. But degree not defined because it came in polynomial form. E power d3y by dx cube. Correct. So that's why. Again, y power 3 in third order log is given. So again, degree won't be defined. Correct. Next part, students, what we get question, very simple. Solution. Now, solution of differential equation. Solution of differential equation can be very simple. It can be a general one, normal. It can be particular. What is general one, sir? Okay. General one means it contains constant, arbitrary constant. See, like I have an equation y is equal to fx plus c. I have no idea what this c is. Okay. Now, the moment we talk about having an idea of c, like somebody told me at x equal to 0, y value is 1. So by putting this value, I got this value c is equal to 5. I substituted here. Now I got y is equal to fx plus 5. So now this became a particular solution. That's it. Nothing more than that. Okay. So I have, let's say, but in exam we won't do like this. Either we'll integrate or differentiate. I'll show how to solve the questions. Okay. So we have this. If I differentiate this function double times, I'll get this. But why? Because it is the derivative. And if I integrate this, I'll get this. But while integrating, we already know what we get, constants. Correct. If we don't have the limit, we get constants. So that will be the general case. And if we put the limit value and get those constants, then it will become a particular solution. So clear. So solutions basically again is of 2 types. I'm recapping it, general and particular. In general, you have this arbitrary constancy, and in particular, you already found out the constant value and you substitute it in the function and you solve it. That's it. Nothing more than that. Okay. Now, formation of differential equation. Let's say we have a differential equation function with n constant. Very important. So we differentiate n times. Okay. And then eliminate the constant. So understand, let's say with a question, form a differential equation representing a family of curves y is equal to mx. Okay, y is equal to mx where m is an arbitrary constant. So how many constants are here, students? One only. So how many times we need to differentiate one? So we got dy by dx equal to m. So in place of m, in order to remove that constant, we eliminated that constant and we wrote dy by dx. Now the equation became x dy by dx minus y is equal to 0. See how simple it is. Okay, so we need to differentiate as many times as the constant is. If we have 3 constants, 3 times. If we have 2, we differentiate it for 2 times. Okay. And then after differentiating, it's not like the work is done. And what you have to do? You have to eliminate those constants and get the whole equation in terms of x, y, and dy by dx and other stuff. Okay, that's it. Clear, everybody? So formation of differential equation. In order to form differential equation, see, very useful for reality in real life situation, like what is where multiple factors are there, you can use this. So you'll say, sir, the moment you go for engineering and all, like what do you say, to study, you'll have differential equation, and there you have to use, you have to form your own differential equation, and then you can use it in like a lot of projects. Okay, so very important, so you should know about it. So, but what is the main point? If I have n constants, I'll differentiate n times. That's it. And then my target is to eliminate it. Three things I need to take care. First, I have to check how many number of constants. That many times I have to differentiate. See, for x, don't get complicated. Okay, we don't have n number of times. Like it will be max 1, 2, or 3. Max. You won't get 3 also, 1 or 2. Okay, mostly we see. And third, eliminate. Clear? That's it. Now, solution of differential equation. Now, in this we have three forms as of now. First is variable separable, means the word also only says variable separable means what? We can separate the variables easily. What you can separate? X one side, y one side. Let's say we have equation x dy by dx plus y is equal to 5. So x dy by dx is equal to what? 5 minus y. Now send y this side, divide this side, and keep dx x dx. That's it. So dy by, or you can send this 5 minus y this side. Minus 5 plus y, we took minus common, is equal to dx by x. So see, this whole x term, x variable one side, y and dy one side. So this is known as variable separable, and you can do separate integration of dy this side, separate integration of dx this side, and you get the answer. So very simple. Nothing was very difficult in this. Correct? Okay. So the moment we say it is variable separable, or will be able to see, if you're able to segregate, what do you say, x variable all things one side and y variable all things one side, it means it is a variable separable form. Okay. Coming to this very important part, but not much questions have been asked, students. Okay, but you should know. You might don't know like when they can, what do you say, ask you something. So let's well prepare it. Just know it. It is very simple. A lot of places and a lot of ways we complicate stuff, but it is very simple. Let's say I have a function x which depends on x and y. I have a function f x comma y. So the moment I'm changing that function x I'm substituting with lambda x, and y I'm substituting with lambda y. If I see a change in the function lambda power n, whatever the degree of the equation is, I get comma x1 y. It is what? A homogeneous equation of degree n. Now you'll say, sir, we didn't get anything, sir. What you said is like we went beyond our head. Let's see with an example. Take a function f is equal to x comma y is equal to x square plus y square plus 4xy. Now, what is the degree of this x square? 2. Degree of y square, again 2. And what is the degree of this combined x1 degree, y1 degree? So combined overall degree is 2. So this whole equation has a degree of what? 2. Now, if I put in place of x lambda x and in place of y lambda y, then what will happen? We'll get lambda square x square plus we'll get lambda square y square plus we'll get 4 lambda square xy. Correct? We got this. So the moment if I took lambda common, what I'll get? Lambda square x square plus y square plus 4xy. Correct. And this is nothing but what? See, if you see that the moment I substituted lambda x and lambda y, I got lambda power 2. Means same thing as lambda power n, since n was equal to 2 here, f x comma y. So whenever the equation is like this, okay, where the moment I substitute lambda, change x and y with lambda x and lambda y, I'll get lambda power n, where n is the degree of the equation. Okay, f x comma y, same function. So it means that it is a homogeneous equation. Homogeneous equation means same degree of what do you say, whatever the degree of the equation is, same degree lambda will have. Nothing more than that. Okay. Now, so how do we identify? By seeing this only. In most of the cases, it will be like x square, y square, like this kind of term, and with practice you'll get it. But in KCET, you what do you say? They don't ask much of homogeneous equations. Confirm question they ask from LD, linear differential equation. Okay. So, but still, I wanted to say. So let's see. Now, a lot of times, what will happen? You'll see dy by dx. comes in this form, f of x comma y by g of x comma y. Here, if both are of like let's say degree 2, so lambda square on top, lambda square on bottom, so it will be cut and we'll get in terms of f of x comma y gx comma y. So it means that here lambda power is what? 0. So whenever it is of first order, whenever it is of 0 order, sorry, whenever we have a homogeneous equation of 0 order, okay, degree 0, so we use substitution y is equal to vx, and then we bring it to why we use substitution to reduce it into separable, what do you say, in variable separable form, okay, to convert it into variable separable form. So we introduce y is equal to vx, differentiate it, so dy by dx equal to v plus x into dv by dx. So done. So now it became variable separable in terms of what you say this one, and you can solve it very easily. Okay, so let's see one example. Let's say we have dy by dx is equal to x square plus y square by xy. So you see degree 2, degree 2, degree 2, correct? So the moment we put lambda x, lambda y, what I'll get? On top you'll say, sir, you'll get lambda square common. Very good. And bottom, lambda square only. So the moment you get lambda square, cut it. So what will happen? Lambda square went home. Okay. So by xy, so we got the same function. So in these kinds of cases, it is what? It is a homogeneous equation of degree 0. We use variable separable, we introduce a new variable to reduce it in the form of variable separable and we can solve it. Okay. Clear? So very simple, but not much questions have been asked. I just wanted to, what do you say, you to know. So homogeneous means same degree. If I'm substituting my x and y with lambda x and lambda y, whatever the degree of my what do you say function is, that degree of lambda should get. So if I'm getting that, it is a homogeneous function of degree n. That's it. Now degree 0 ones, we can introduce another variable and we can convert into variable separable and solve it. That's also done. Now the most important part, linear differential equation. Okay, most of the questions are always asked from this topic, linear differential equation. Now what about linear differential equation? See, it will always be of the form dy by dx plus p into y is equal to q. Now student always understand this p and q, either they are the functions of x, they're the functions of what, this downward, they're the functions of x, or they can be constants. So in the first example, dy by dx plus y is equal to sin x. See, sin x is a function of x, and this nothing is there means 1 is there. So 1 is a constant, so that is correct differential equation. Second one, if you see dy by dx plus 1 by x into y is equal to e power x. This is a function of x, and this is also a function of x. So again, it is in the form of dy by dx plus py equal to q. Now here, what they ask in case it integrating factor. What is integrating factor? E power integration pdx. E power integration pdx. E power integration pdx. So this one you need to write, and this equation you need to write in your short notes so that you can understand. You can do it very properly. Now, since we have very less time now, so we'll be going on a bit more faster. Physics, I'm putting up like what do you say, very in a very fast way. I'll put up all the concepts, all the important formula, and then we'll start the pyq. Okay, so we'll try to wrap up physics by within 2 or 3 days. Okay, by most probably by Monday we should be able to wrap up everything. Okay, now how do you find the solution? Y into integrating factor is equal to integration of integrating factor into q dx. That's it. This is our answer, final answer. Okay. Now, a lot of times, now before understanding that, this is the most important thing because you'll be using this one a lot. What is this formula? E power log of base is E. Elephant also is equal to elephant. Now I have taken elephant so that you can remember this for a long time. Whatever is here, if it is x here, if it is f of x here, f of x will come. Okay, you can't say this e and e gets cancelled and log cancelled, but just remember it like this. Okay, so e power, or you can say e power log of whatever dabba it is, base will be this dabba only. Okay, if you can remember this much, will be a very important thing and a very important formula. Okay, clear? Now, a lot of differential equation we won't get in the form of dy by dx. We can get in the reverse form, dx by dy. In that case, what will be the change in the equation? It will be dx by dy. Now, px, whatever here it is, what is the opposite will be here, and p and q will be the functions of y. P and Q will be the functions of this one. Clear? So earlier it was dy by dx plus p y is equal to q. So here p and q both were the functions of what? X. Correct. And y opposite was there. Correct. Here just opposite it became. So p and q are functions of y and constant here in this case. Integrating factor, what is the change? Here integration e power integration p dy. Here we had e power integration p dx. That's it. So integration, the change is only of dx and dy. That's it. What is the solution change? X into, here it was earlier y into integrating factor is equal to what is say integrating factor into q. Here it was dy, here it was dx. If you remember correct, integrating factor into q into dx for the other equation. Again, I wrote e power log of base e gx also a function gx. You'll get that function gx only. That's it. So the whole what is a differential equation sums up to this three kinds of questions we get. I'm recapping it: one order degree, one of either from formation or solution, and third mostly we get from linear differential equation. That's it. So differential equation, don't worry, you can score 3 out of 3 each set of paper. Okay, each year. It's very easy, very simple. Okay, and on 20th we are solving one live paper, either 2020 or 2019. Okay, be there live with me. We'll be solving the paper on the YouTube only. Okay, first will be a maths paper in the morning, and then will be a physics paper in the evening. That's it. Okay, that's all for now. What do you say? Like the channel, do subscribe, comment. Very important. What is your honest opinion, view, and views? Okay, and if you're a serious KCT student, okay, you're preparing seriously, so work hard, watch all the videos, make short notes, very important. Upload it on the website. Link is already given in the description. We have the Telegram channel. Join the Telegram channel for more further updates and the PDFs. And that's it. If you have any doubt, put it on the what do you say WhatsApp group also. You can join it and you can put your doubts. Pretty much I reply almost around within a gap of like 2 to 3 hours. So that's it. Okay. Keep it till here.